Hey guys, so today we have another lab solution video working on activity number 10.15, and we're going to be working with classes and objects today. So a little bit of an introduction to object-oriented programming and C++ through classes. I feel like I say this every time, but this is just such exciting stuff. Programming in general, just so exciting, right? So in this lab, we're writing classes to see how they work with data members and member functions. So we've talked plenty about data, well, at least we've talked about member functions of certain classes that we're using via these include statements. Like for vector, for example, we've used the pushback function, we've used the back function, all sorts of stuff to kind of work with those standard defined libraries, right? So let's go ahead and get into the problem. So imagine we lived in a world where everybody would be given money to travel anywhere in the world for a vacation. So essentially we want to decide, okay, where are we going to go and how much money would we request? So these are going to be our two data members inside of our vacation class, right? So we'll refer to the main to know what parameters the functions would take and what they would return. So we'll take a look at that in a second. So we have a vacation class with these members as discussed. Destination will be a string, whatever city, country, what place is what that it is we're going to. And then the cost in thousands of dollars. So if we say I want 5, then we want $5,000 to go on this vacation to the specified destination. All right. So first of all, we just want to work on getters and setters. Getters, setters, accessors, mutators is the more formal terminology to refer to them. Essentially, we want to work on some functions in our class that are going to go ahead and either return the value of one of our data members, or they're going to change the value of one of our data members. So a getter for the destination would just return what the destination currently is, and a setter would just modify that value. So let's go ahead and start with that. So we can see that set destination set cost in the main accepts the user input for the respective field and passes it to the function. So let's go ahead and look down there. So there's lots of red squigglies because we haven't actually defined anything yet. But if you see, we'll have our vacation object, set destination, and then our destination string as an argument. Notice here that this is not being assigned to anything, not that functions with return values have to be assigned somewhere, but it's not being printed anywhere, so we can kind of safely assume that this is going to be a void function. And why shouldn't it be? We're just modifying a value, and that is all. So our setters, our mutators, are going to be void functions. So yeah, just to reiterate, our setters are going to take the user input and assign that value to the data member and go ahead and update that internally through the class. And then we want to write the getters, which just go ahead and return those values. So if you run the program, you should get this kind of output. So let's go ahead and just start working on these getters and setters. They're fairly straightforward, right? So if we're looking up here, we've got all these question marks because we're supposed to figure out what we're doing. As I mentioned, our mutators, our setters are going to be void return types. So we can just go ahead and change that now. Get these to be void. And then our argument for set destination is just going to be some kind of a string that's going to overwrite the current destination as stored in this private variable. Actually, real quickly, before we go ahead and write the getters and setters, let's just talk about what this private versus public distinction is, right? So public data members, public functions, anything that's in this public specification can be used by any user of our class. So if someone goes ahead and imports our vacation class, then they will be able to use anything that is in the public domain. Whereas the private members can only be used, the private members and private functions, you can also have functions in the private section, can only be used within the class itself. So that will just kind of help us to organize our code a little bit. So yeah, back to the mutators here. So we want to go ahead and pass a string for our destination. And always ask yourself when we are writing parameters, is this value going to change? If the answer is no, pass it as a constant reference, right? So we have a constant string, and we can call this, so there's two conventions you can kind of follow when we're writing functions and parameters for our class. So if you want to use the same identifier as your private data member is, then you will just be using the this pointer. So what that would look like is you'd say, okay, destination, and then you'd say, we are saying that this, which refers to the class object. So like if we look at main, let's say this code, this setter, is being executed. So if we look at set destination down here, this would refer to the holiday 1 vacation class object, right? So we're saying, okay, set this object's destination variable equal to the destination parameter. Destination. I think I spelled that right. So yeah, that's kind of all there is to it for this. Another convention is to use like a slightly different name. So you could have like dest or something, and then you wouldn't have to explicitly pass in the this this pointer to access the object's data member. So you could just do something like this. Destination is equal to dest, and then C++ would know, hey, destination refers to our private data member, and dest refers to the parameter. Personally, I prefer to use the same name and just use the this pointer because I think it makes it more obvious that these are referring to the same kind of data. Right, okay, so next setter. So now we just want to go ahead and set the cost, so it's going to be the same deal. We're going to go ahead and pass in an integer, and that integer is going to be used to modify the current, is going to be, the value of the parameter is going to be assigned to the data member cost, right? So we can have const integer cost. Well, we don't really need to pass by reference. Cost, not const. And then even the const is a little bit unnecessary here, but I'm just trying to develop good habits for you guys, right? So like you think to yourself, hey, is this changing? No, we're not changing it. We're using it to make an assignment, so go ahead and just make that const. But a little bit unnecessary and maybe not so so widely seen for primitive types like integers. So we're going to go ahead and say this cost. Oh yeah, and in case you guys haven't been familiar for whatever reason throughout your lectures, this arrow is just saying, hey, let's dereference a data member of a pointer, right? So this is the object, and so normally how we would access data members of an object is we would do the dot operator, right? We would say like this dot destination. But since this is a pointer to memory, we want to go ahead and dereference the value at that location. You guys will learn like a lot more thoroughly about pointers in 211 and 261. So don't worry too much about if the syntax is scary or you don't quite understand what a pointer is yet. So yeah, this cost equal to cost, and boom, we have our setters. And getters are arguably even easier. It's all easy. I know I've already spent quite a long time talking about it, but just want to make sure we go over everything. So you just have the return type is whatever your public or private data member is that you want to return to the user. And so like in this case, destination, we're going to be returning a string, and then it's not going to take any arguments because the class already has access to the private data members inherently. So we can just say, okay, return destination. That's all there is to it. Did I spell something wrong? Nope. Yeah, there we go. Return destination. Awesome. And then same thing for cost. Just get this integer. Get cost. No parameters. And if we look at main, you can see when you use get, there are no arguments in any of these calls. So that can kind of hint you into the fact that you won't be needing anything there. And then, excuse the deep breath, we want to go ahead and just return our cost. So now we have our getters and setters done. Sweet. Okay, so constructors. So in general, what constructors do is we're just going to, they just create an instance of our class, right? So like, for example, string, this is a class, right? So when you say string destination, this is just calling the default constructor of the string class, right? Same here with the vacation. We have our vacation object specified by the data type, and then we're going to just say, okay, here's the identifier for this vacation object. And then when you don't call it, with any sort of specific arguments, if it's defined so that you can do it that way, then it will just call the default constructor. So that's what we want to go ahead and define here. We want to define our default constructor. And our instructions say that we just want the default constructor to accept Alaska for a destination name and 3 for cost as the default value. So if we wanted to be kind of compact, we could all write this in pretty much one line. But just for clarity's sake, I will do it the standard way. We'll just assign our data members a value within the constructor body. So we'll just say destination is equal to Alaska, and our cost is equal to 3. And that's it. That's all there is to it. We're just saying, okay, every time we make a regular default object of our vacation class, make sure that it has these values to start. Cool. So now onto the last step. We just want to go ahead and write our compare function. So this is the only function we have with any actual logic. So let's go ahead and look through this. So you want to write a compare function which can compare the place and cost of your request and tell you if you have requested for that place or not. The compare function should compare 2 objects, right? So this is a big thing. It's bolded on purpose. So it's comparing 2 objects, so 2 vacation class objects, right? And return true or false. Not exactly sure like what's going on with the prompt there, but that's kind of, it should return true or false based on whether or not you have requested for that place yet. So if we go down to main and we take a look at some example usage of this compare function, we can see that we have 2 holiday objects. Holiday 2 is here and holiday 1's up here. And then after using the getters and setters, they have some values, and then we're just going to say, okay, holiday 1.compare with holiday 2. And so the idea here is we're just saying, okay, clearly we have another vacation object as the parameter for, well, in this case it's an argument because this is a function call, but when we go back up there and define it, we're going to have a vacation object as a parameter for a vacation member function. And this might seem a little weird at first, but it's actually very, very common, used for all sorts of things like operator overloading and stuff like that. But okay, you can see that it returns a Boolean because we're assigning the value of this function call to a Boolean variable, and that it's passed in a vacation object. So let's go ahead and take care of the return type and the parameters. So I'm going to have that bool, and then we're going to have a vacation object. So again, always ask yourself when you are, I'm just going to sound like a broken record here, but ask yourself, are you changing this parameter within the function's body? And so we're just comparing whether 2 things are true or false. And so at no point are you actually changing the second vacation object that you are comparing this vacation object with, right? So in that case, we should just use a constant vacation. Constant vacation, and we call it vacay2 or vacation 2, something like that, or holiday 2, whatever. Or I think the most common convention is to use something like other vacation, because you have this and you have other, right? So other vacay is what I will call it, right? So we have this constant reference parameter, because, I mean, with this kind of object, it's small enough that we could pass by value and it wouldn't be a big deal. It's just a string and a cost. So it's just a string and an integer. But it's good practice to make sure that we're passing by reference with objects in case there's a lot of data that we don't want to go ahead and copy. So if we refer back to the prompt, we just want to return true if you've requested it before, so hence in the other object, and false if not. So let's just go ahead and create a simple conditional to take care of this task. So I want to say if, and then we're just basically going to be doing like a member-wise comparison. So what I mean by that is we're going to take each data member and we're going to compare them to each other, and if they're equal, then we've requested it before, and if they're not, then we have not. Yeah, for the purposes of this program at least, you can make an argument that there exists another object where you've requested before, but yeah. So let's go ahead and say, okay, so if this dot destination is equal to, and you can do this direct equality comparison because of the way that the string class is implemented in C++, but other languages won't allow you to do it this way. So you can use, yeah, so we'll just forget about that for now. So this destination is going to be equal to other vacay dot, right? So we're using the dot operator here instead of this arrow operator, and that's because here we have a reference parameter, and here we have a pointer. Again, the distinction for what exactly that is will be made more clear in 2.11, but basically you just want to understand that we're already accessing the memory at this point, and here we need to kind of dereference this data member. So we're going to say other vacay.destination. And so that will go ahead and verify for us that the destinations in both of the vacation objects or holidays are the same. And then we also want to go ahead and compare the integer cost. So we're basically just overloading the equality operator. You guys just haven't talked about how exactly that would look yet, but secretly that's what we're doing. So we want to say, okay, and the cost, or this cost, right? This cost is equal to other vacay.cost. Then we want to, oh, did I do something wrong? Nope, it's just figuring out. Then we want to return true, right? Because if the member-wise comparison is true, then the entire comparison is true. And then otherwise, we want to return false. You can put an else here if you want, but it's kind of unnecessary. It depends on your kind of style. But yeah, if this doesn't execute, then it's going to go ahead here, so you don't really need the if. Or, I'm sorry, the else. But yeah, that's kind of all there is to it, guys. We have worked with some mutators here. We have written some accessors here, so we're just accessing private data members, and here we are mutating them, changing them, getting them, however you want to refer to all this stuff. And then we have just one public member function that we've implemented, which is just basically our vacation objects equality operator. So it's kind of the equivalent to this double equals, right? So yeah, we have learned a little bit about classes. Let me see, is there anything else that I should go over before we get out of here? There's also another, you'll learn more about this if you see more about object-oriented programming in your future courses, but there's also a protected section. So we have private, public, and then in between these two would be protected. So that's just saying, okay, this can be accessed by children of this class, but it cannot be accessed by a class user. So yeah, that's not too important at this level. But then also another thing to take note of is how the class is specified. You just have a class keyword. So you've got the class and then the class name, and then you've got these curly braces, just kind of like a function or like a struct. And yeah, and then there's a semicolon at the end, just like a struct. But yeah, guys, that's all there is to it. Hope you learned a little bit about classes, and I will see you in the next video.